All right, welcome to the Unit 6 study guide, okay, quadratic of equations. For number one, they ask us which of the following is the graph of the function, and they give you the function. There are a couple things you can tell just by looking at the equation. The first is whether it opens up or opens down. If the first coefficient is positive, that means the number that's on the x squared, if that's positive, that means it opens up. So since letter A opens down, okay, it opens up facing this way, we know that that's not the answer. Okay, so we know that the answer has to be either B, C, or D because those both open up. Okay, now what we need to look at is we can also find the y-intercept by looking at the equation. Okay, so if you look at the last number in the equation, or the constant, this is the constant. Okay, whatever that number is tells us where it's going to cross the y-axis. The y-axis is the line that goes up and down. Okay, vertical. Okay, so judging from this, we know that the y-intercept is going to be 1. We look at letter B. Does this graph cross the y-axis at 1? No, it crosses at -1, so we know that's not the answer. Where does this one cross the y-axis? It crosses at 0, so that's not the answer. And then we look at D. Where does this one cross? It crosses right here at 1. So it opens up. The y-intercept is 1, so that means this is the answer. So D is the correct answer. Okay, it's the same kind of deal for number 2. This is an exponential function. Now what you need to look at is this parent function right here. Okay, whatever the k is, whatever the regular number is, or the constant, that tells you where it crosses the y-axis, similar to what it did in number 1. Okay, so if we look at this, they ask us to find what k is, so all we do is look at our graph and find where it crosses the y-axis. It crosses here at -2, so that means k is equal to -2. Okay, if it crossed at 0 here, it would be k equals 0. If it crossed here at 2, it would be k equals 2. If it crossed here at 4, it would be k equals 4. So all you do is find out where your graph crosses the y-axis, and that's the answer. For number 3, they give us a function, a quadratic function, and they ask us to find the vertex. Now, the equation for finding the vertex is, the axis of symmetry is x equals -b over 2a. Now, that gives us half of the vertex. Okay, so the a and the b and the c come from the coefficients in our original equation. The coefficient on the on the x squared, is a. The coefficient on the x is b, and the regular number is c. Okay, so now we just plug in what we have. The opposite of b is 4, so it's the opposite of 4 divided by 2 times a, and a is 2. Okay, so we simplify that, we get -4 over 4, and that reduces to -1. So the x coordinate on my vertex is going to be the same thing as my axis of symmetry. The x coordinate on my vertex is -1. Okay, so I've already got half my problem done. Now what I have to do is I have to plug my answer for the axis of symmetry back into the original problem, and then solve and get another answer. So my original problem says f of x. F of x is the same thing as y. They're synonymous. They mean the same exact thing. Okay, so all I do is plug in my x, and then I simplify. It's important here that you do -1 to the second power first, and then multiply it times 2. 2 times 1 is 2. 2 minus 4 is -2. And -2 minus 6 is -8. So my vertex, okay, is -1, -8. And it's important when you write down the vertex that you write both numbers. You have to write both the x and the y. Number 4, they ask us for the axis of symmetry. And the good thing about it is we already found the axis of symmetry in the other problem. Okay. The x coordinate of the vertex is our axis of symmetry. So x equals -1 is the answer for number 3. And we used x equals -b over 2a to get that. The axis of symmetry, by the way, is the line that bisects your parabola, or the graph of a quadratic equation. Okay. So anytime you're looking at a parabola, your vertex should take you right to the middle of your parabola. If your axis of symmetry is correct, it should take you right to the middle of your parabola. Number 5, for the same problem, they ask us to find the roots. The roots are where the graph of your quadratic equation crosses the x-axis. So your roots are here if you were to graph it. Okay, you can't use a calculator for this, so you can't graph it. But if you were able to use a calculator, just understand where your graph crosses the x-axis is our answer. So to get the answer for the roots without a calculator, all we do is factor our given equation and then set it equal to 0. So we're going to do arc it, stick it. Well, actually, we can factor out a 2 first. So we take a 2 out. That's going to make this 2 times x squared plus 2x minus 3. Then you factor what's on the inside. We're looking for two numbers that multiply to equal to -3 and add to equal +2. That's what we use our big X for. Two numbers that multiply to equal -3 and they have to add to equal +2. Okay, so let's see if that works. 3 minus 1 is +2, and 3 times -1 is -3. So that satisfies both my conditions. So that's what I put here. A +3 and a -1. Okay, once we get to this point, we just set all three of these equal to 0 and solve. The opposite of +3 is -3, so you subtract 3 from both sides. The opposite of -1 is +1. So we get our three answers. Okay. Now, 2 is not equal to 0. That's an untrue statement. So that's why that one is not considered part of our answer. So our two roots, the place where our graph crosses the x-axis, they cross at x equals -3, and it crosses at x equals +1. And the last question they ask us for the y-intercept, remember the same thing applies for number 2, and number 1 applies for this one. Remember the constant, the regular number at the end of the problem is where it crosses the y-axis. So we go back to our problem and we look at it. What is the regular number in the problem? The constant is at -6. So that means your y-intercept is -6. Or -6. Same deal, same thing. Now this is either an exponential growth or an exponential decay equation. Problem, it says that the Charlotte Times newspaper company is decreasing in value. So since it's decreasing, it's going to be exponential decay. Okay, but they give us the equation by they give us how it is decaying. They give us this equation: y equals 2,000. 2,000 is how much was there in the beginning, or how much money something was worth in the beginning, or how much it weighed in the beginning. So it was 2,000, and then it went down 67% every, and X stands for time. So every year or every month or every day. Now, according to this problem, they ask us, they say, what's the value of the company 3 years after it started? So we're going to plug 3 in for our time, which is x. So we're gonna replace that x with the 3. Okay. And then we simplify. Now this part is calculator active, so we could just put this in our calculator. We pull up our calculator, and all we do is plug it in just the way it looks. 2000 parentheses 0.67 close parentheses, and then you hit the caret button. That's the arrow key. That's how you put in an exponent bigger than 2 if you need to put one in. Okay, it looks just like it does in our problem. We hit enter, and that's our answer. Our answer is $601.50. Since this is a 6, that rounds to 3. So $601.53. Again, it says you have to round 2 decimal places. It's important that you understand. You look at the second decimal place, and the number to the right of that one determines whether you go up or down. If that third number is 5 or less, that stays as a 2. I'm sorry, if the number is less than 5, that stays as a 2. And if it's 5 or more, that goes up. So since that is a 6, that's why we changed that to 0.53 instead of 0.52. So this is our final answer. Okay, the next problem, they tell us we have a house that appreciates by 6% each year. Ms. Smith purchased a 3,000 square foot house for $200,000 back in 2001, and they want to know what's the value of the home in 2014. So we use the formula that they gave us. A equals P times 1 plus R to the T power. Again, T stands for time, R stands for percentage rate as a decimal, and P stands for the amount of money that your house was worth in the beginning, or the amount of money that you put in the bank in the beginning. So our house was $200,000 at the beginning. The percentage rate was 6%, but we have to change that to a decimal. So you do that by dividing by 100, or moving your decimal point that starts here to the left 2 times. 1, 2. And then fill up the hole with the circle. So it's 0.06. Don't forget to change the percentage to a decimal. And the T, they want to know how much your house is worth after how many years. Well, if they asked for 2014, we started in 2001. How many years between 2001 and 2014? It's 13 years between them. So that's why we put a 13 here. Okay. And then we just go put that in our calculator and see what the answer is. We hit enter and we write our number down. 426585. It said round to the nearest round 2 decimal places. So we look at the third number. That number is a 2, so that stays as 0.65. So 65 cents. Okay, always look at your numbers and see if it makes sense. Is your house supposed to be worth more money than it was in the beginning? Yes, because it appreciates. That means it should be worth more. If it says depreciate, it should be worth less. $426,585.65. Okay, number 9. They ask us to find out which equation corresponds to the graph that they gave us. So we can tell a lot of things from our equations. We can tell the y-intercept by looking at the last number or the constant. Um, this graph does not cross the y-axis, so that doesn't help us. This is the y-axis. Our graph doesn't cross, so we can't use any of those to tell whether which ones are go with this graph. So now the other thing that we know is we can find the axis of symmetry. And the axis of symmetry, again, is the line that bisects this graph. So it's the line that goes down straight down the middle of this graph. Okay. So as we see, the line that goes down the middle is at 4. So our axis of symmetry is x equals 4. Okay. That's where we go to find the line. Starting from 0, you count over 1, 2, 3, 4, and that bisects your graph. So whichever one of these has an axis of symmetry of x equals 4 is our answer. Our formula is x equals negative b over 2a. Okay, so I'm going to plug in this 8 and divide it by 2 times that 1. But that's going to be negative 8 because it's the opposite of b. So that means that for a, we've got a negative 8 divided by 1 times 2, which gives us a negative 4. That's not what we needed. We needed a positive 4, so that's how we know a is not the answer. Okay. Then we do the same thing for all the rest of the problems. Let's go to b. We do the opposite of negative 8 over 2 times 1, which is 2. The opposite of negative 8 is positive 8, and 8 divided by 2 is 4. So we get an axis of symmetry of x equals 4, so we know that's our final answer. B is our answer for number 9. Okay, number 10, they asked us to find the roots. Again, the roots are where your graph crosses the x-axis. Okay, so you can use a calculator for these. So you can do it without a calculator by getting 0 on one side, factoring, and then setting all your factors equal to 0. But if they allow you to use a calculator to save yourself time, you just go ahead and hit y equals and put it in the calculator. Now we have to get 0 on one side before we can do that though. So we've got x squared minus 3x minus 56 equals negative 28. The opposite of minus 28 is plus 28. So we add 28 to both sides, and we get a new equation of x squared minus 3x minus 28 equals 0. Okay, and then this is what I put into the calculator to find our roots. So I put in x to the second power minus 3x minus 28 second trace. And this can give us, those are the two buttons that we hit to find the zeros, which are the solutions, the minimum or maximum, which is the vertex. Okay, but they asked us for the zeros, so we hit number 2. It's going to say left bound. You always put in a negative number. I always put in negative 10. And then right bound, you put in a positive number. I put in positive 10. Enter. When the calculator says guess, that's the calculator's way of asking you, do you want me to get the answer? Yes, we want you to get the answer. So we hit enter. Okay, it gives us one of the zeros. Okay, one of the zeros is 7, positive 7. So we go look, see it says x equals 7 on our calculator. So we go look and see which one of these has an answer choice of positive 7. The only one that does is D. So that is our answer. Okay. Now the other answer they said is negative 4. So if you want to double check that one, you just use the left arrow key to go over to where it crosses the x-axis, and you see that that's approximately negative 4. So we know we're correct. Okay, number 11, it says what are the roots of the quadratic? In our previous problem, we understand that where your graph crosses the x-axis are the solutions or the roots or the zeros. So they asked us to find the roots. We know that that means the same thing as the zeros. We go see where it crosses. So where does this cross? That crosses at 0, and that crosses at 1, 2, 3, 4, and that crosses at 4. So my answer is going to be 0 and 4. Real simple. Okay, now number 12, they ask us to find the perimeter. I'm sorry, they ask us to, yeah, they do. They ask us to find the perimeter. So to do that, we need to find x, so we can find the length and the width of this rectangle. Okay. To do that, We know that the area, and they give us the perimeter. That's also very important. They give us the perimeter. So we know our formula is the perimeter equals 2L plus 2W. Okay. But we don't know the length and the width, so we have to find it. Okay. I'm sorry, we're going to use the area because they gave us the area. I apologize. Area equals length times width. We know the area. They told us the area is 18. We know the length. It doesn't matter which one's which on this side. And then our width is x. Okay? So we need to multiply, get 0 on one side, and then factor. That's how you get the answer when they ask you, when you're trying to find the roots. So we must multiply this out. That's going to be 4x squared minus 21x. We use the distributive property right there. Okay. Now we have to move this plus 18 to the other side. The opposite of positive 18 is negative 18. What we do to one side, we must do to the other. 18 minus 18 is 0. That's what we wanted on one side. And now we can put this in the calculator and find the roots. Okay. Calculator. I go to y equals. I put my problem in. 4x to the second power minus 21x minus 18. Okay. I hit second, calculate, and what am I trying to find? The vertex or the zeros? I'm trying to find the zeros, which is the solution to the problem. So I go to 2. I put in negative 10 for left bound, positive 10 for right bound. Okay. So I get the answer of 6. Now, for those of you that kind of understand that there are usually two answers, you do not use this answer that's over here because, as you can see, that's a negative number. Okay. And if you tell me that the distance from here to here is a negative number, that's impossible. It's impossible for distance to be negative. It's impossible for height to be negative. It's impossible for you to be negative 13 years old. So it's also possible for the distance from here, one point to another, to be negative. That's why we don't use the second answer. So that's why we're going to use 6. Okay, x is equal to 6. Okay. Now we're going to go back. They asked us to find the perimeter. Well, we know if this is 6, then opposite sides are equal, so that's 6. We plug in a 6 here and we multiply. 6 times 4 is 24, and 24 minus 21 is 3. Okay, so all we did was plug in a 6 in place for x. And then opposite sides are equal, so that means that's 3. And to find the perimeter, you can just add up all the sides. 6 plus 6 is 12, 12 plus 3 is 15, and 15 plus 3 is 18. So our perimeter is 18. Okay, number 13, they want us to find the height of the object after 3 seconds. You should always draw a picture when they give you an equation and they talk about throwing something in the air. That's called projectile motion. So if I shoot a rocket from the ground or throw something in the air, it's going to go up and eventually come down. That's a parabola with the negative first number. That's what that is. Okay? So they want to know what's the height of the object after 3 seconds. Well, this is the highest point. That's the maximum height. And that's also where you find the vertex. Okay, so if it asks you for the maximum height, you find the vertex, and x is how long it takes you to get to its maximum height, and y is the maximum height. Every time. And you get all that from just finding the vertex, which we did, I think, for number either 1, 2, or 3, one of those early ones. But they didn't ask us for the maximum height. They just asked us what's the height of the object after 3 seconds. So without a calculator, this right here stands for height. They tell you h parentheses t means the height in feet. That's what that says right there. So if I want to know the height, I just plug in the time and solve. So without a calculator, you can plug in 3 in place for t and get the answer. With a calculator, it's much easier, but you can still do it. All you do is just go to y equals, plug your equation in just like usual. You can't use t, so we just use x. No matter what the letter is, you're going to use an x when you put it in the calculator. Okay, double check to make sure it looks right. Okay, and then I make a table of values, second graph, and that tells me the height of the object after a certain number of seconds. So this is telling me the height of the object after 1 second is 65. The height of the object after 2 seconds is 94. 3 seconds is 87. 4 seconds is 44. Okay, so we see that after 3 seconds it should be 87. We know that that's A. Okay. And for those of you that like to do it without a calculator, this is what you would put. This is what you would solve. You just plug in 3 seconds in your equation and simplify that, and you should get 87 if you do it right. All right, number 14. They say, how long will it take for the object to hit the ground after takeoff? Okay, so they're telling you blasting something into the air, and of course, it's going to eventually come down. Okay. They give you the equation, and then they tell you that v sub 0 is its initial velocity. So they tell you the initial velocity is 550. So all you have to do is plug in 550 in place for v sub 0. Okay. Now we have a quadratic equation because the highest exponent is 2. We know that we can put it in the calculator and find out how long it's going to take for it to hit the ground. So we go to y equals, again in our calculator. We plug it in, 550 minus 25x squared. Okay. Second table, and we go to the table. Okay. Now, this stands for height. This stands for the height. This also stands for y, because y is the height, always. So, you go look on your calculator, and you're looking for when something hits the ground. When something hits the ground, what's the height? It's going to be 0, always. When it first starts on the ground, the height is 0. Goes up into the air, however high it's going to go. It comes down, and once it hits the ground, it's also 0. The height is 0. So you're going to find which one of these has 0 for y. Now I can't tell. As you can see, it's going down from 150 to negative 75, so it goes down. So I can't tell from the table. So the other way you could do it is second trace, and you can find the zeros, because this is where it crosses the x-axis, which is the ground in this case. So you go to number 2. Left bound is negative 10. Right bound is positive 10. Enter. And it tells me when the height is 0, it's been in the air 4.69 seconds. So that's the best way to do it, is to put it in the calculator and find these zeros. Okay? Because when this ball comes down to earth, after a certain amount of time, the height's going to be 0, and that's what the zeros give us. So number 2, second trace, number 2, a negative 10 and a positive 10, enter, and that gives us the 0. It's been in the air 4.69 seconds, and that's when it hits the ground after that amount of time. Anytime you see the equal sign that looks like it's squiggly lines, that means approximately. That means it's not exactly that, but it's very, very, very close. So approximately 4.69 for number 14. Number 15, they ask us for the maximum height. Again, if you draw a quick picture, the maximum height is here. That's where the vertex is. Oops. Okay, so you have to find the vertex. If you find the vertex, the x is how long it takes to get to the top, to its maximum height, and y is its maximum height. So, calculator again, y equals, plug it in. Second trace. Now, is this the highest point or the lowest point? As you can see, because we drew our picture, it's easy to tell that it's the highest point. So you need to press number 4, which is the maximum. That's what we want, the maximum height, not the minimum height. So again, left bound is -10 and right bound is +10. It says yes, you say yeah, you wanted to guess, and it gives us our maximum. After 1.26 and some change seconds, it's reached its maximum height of 53. And that's what they want, is the maximum height. Oh, I forgot something. I apologize. I didn't put my X right here. And that messed up my answer. So I go second trace again. It's still maximum. -10, +10, and guess. Okay, and the answer is 55.08. I apologize. So it's real easy to mess up, so you got to make sure when you put your stuff in there that it's exactly the way it is in your original problem that you wrote down. Glad I caught that before I turned my paper in. Five point oh eight. Okay, now number 16. It said we had a ball that's dropped over the side of a school building. Okay. It said the height is 121. So you drop the ball off the building, it was like that. Okay, they give you their equation, or our equation. They say H stands for the height, T stands for the time. Okay, they say how long did it take for the ball to hit the ground. So when a ball hits the ground, what's its height? 0. Okay, and now it says you need to find the time, so you solve for T. So you can do it with the calculator or without. We'll do this one without the calculator. You subtract 121 from both sides. That gives you this. Then you divide both sides by -16. And you get T squared equals 22. I'm running. And then to get rid of a square, you square root both sides. And the answer is approximately 4.69 for the time. So that's how long it takes your ball to hit the ground. The other way you could do it with the calculator is you go to y equals, plug your equation in, Second trace again, and then I need the zeros because the height is 0. So that's number 2, negative 10, positive 10, and an M. And I'm sorry, I made a mistake here, right here at the end, making all kind of mistakes. When I divide these two numbers, I get this. And then I take the square root of 7.25 and I get 2.75. I'm sorry. Got something confused. And now when I go to my calculator, the good thing is I checked it in the calculator and I got 2.75. And when I put it in my calculator, that kind of let me know that I had done something wrong when I did my problem. I was looking at the wrong number when I was putting it in. No excuses, it was wrong. But because I checked it and because I used another way to do the problem and I saw that I had a discrepancy, that allowed me to go back and be like, what did I do wrong? And I found it and I changed it before I turned my paper in. So that's why, you have to double check your problems before you turn your paper in because this is real complicated stuff and we make mistakes. So you do it as many times as you have to do it to get it right. So our answer for that problem, it takes 2.75 seconds for that ball to drop from the top of that building and to hit the ground. Okay, number 17, they ask us how high did the keys reach? Okay, they say you're gonna throw something up to the sister. So the sister's standing on a balcony. Okay, and Jake is throwing the keys up. Okay, Jake's throwing the keys up to his sister. Okay, it says that her hands are 15 feet above the bottom floor. 15 feet above the bottom floor. The bottom floor is the bottom. So it's 15 from there to the bottom. Okay. They said he throws the keys with an initial velocity of 20 feet per second. That's why this middle number is 20 in this equation. How high did the keys reach? I'm sorry. We want the maximum, which is the vertex. So again, go to our calculator, plug our equation in. See, I have two negatives up here. Gotta get rid of one of those or it's not gonna work. Negative 16x squared plus 20x plus 5. And if we're trying to find the highest point, we're trying to find the vertex. Second, calculate. Is our vertex the highest point or the lowest point? It's the highest point. That's a maximum, as you can see from our picture. That's the highest point as far as where the keys go. So you get number 4. Negative 10. Positive 10. Okay. And we get the maximum height, 11.25. Remember, maximum height is always y, and the time that it takes to get to its maximum height is always x of the vertex. Those are the pieces of the vertex. So we get 11.25. Now for the bonus, or the second part of the problem, they ask us, did the keys reach Jake's sister? Okay. Well, how far is the sister from the ground? 15 feet. How high did the keys go? 11.25 feet. So was that enough to reach the sister that's 15 feet? No, 11.25 isn't enough. So the answer to the second part of the problem is no, those keys didn't reach. They fell short. Hope this really helps. Rewind and pause and start and use this to study as much as you need to. It's important that you go back and do these problems without the help of a video or a study guide or answers that the teacher gives you. You work the problem out, get your answer, and then go back and look at the answers that we give you. And once you're able to do them without the study guide or without this video, then you're doing very well for yourself and you do good on the test. So look out for Unit 7 in the coming weeks and have a good one.